Hello everyone. In this video we're going to learn how to solve a formula for either a given variable or a constant symbol. Basically, a formula is nothing more than an equation which contains more than one variable or constant symbol. Symbols like pi or e or c that you may have seen before. These represent some natural constants. C, for example, is the speed of light. E is a number you'll get to know about very soon. And pi, of course, is the number we use for calculations of circumference of a circle, or once you get into trigonometry, it'll have a lot more applications as well. Basically, our goal is to take a formula like the ones we see here and solve it for one of the letters which represents a variable or one of those constant symbols we mentioned earlier. And for example, here's a formula which deals with compound interest. Obviously, the field of study would be business. Here's the ideal gas law from chemistry, the potential energy formula from physics. Here's a area formula for a trapezoid from geometry. So we'll be looking at these, and we'll start with some real simple ones and work our way to more interesting ones as usual. Let's go ahead and start by solving the ideal gas law for V2. Basically, P stands for pressure, V for volume, and T for temperature. So when you have a situation like you have two fractions that are equal to each other, this in algebra is called a proportion. So the best way to go about solving a proportion is to recall the principle of cross multiplication, which, if you recall, says if A over B is equal to C over D, then we can cross multiply and these cross products will be equal. And we end up with, this implies AD is equal to BC. That, of course, is a very simple fact which is easy to prove. And since you want to improve in mathematics, you have to basically understand the reason for everything. So let's take 1 minute to prove that. Notice that if we start with A over B, so here's the Y, equals C over D. Notice that we can multiply both sides by the LCD, which is BD. And here we can cross cancel these on this side and these on this side. And that's how we end up with AD is equal to BC. All right, so now we want to use this in our situation here. So notice we can go ahead and say, therefore, we're going to set the cross products equal to each other. So we get, therefore, P1, let me go back to my previous color. So we get P1 V1 T2 is equal to P2 V2 T1. And keep your eyes on the target. Remember, we're solving for V2. So we're going to try to get V2 by itself, which means we need to get rid of the P2 and the T1. And these are all being multiplied. So we're going to divide both sides by P2 T1. So we cross cancel, notice the P2s and the T1s, and on this side we notice that we have no cross cancellation, so we end up with V2 is equal to P1 V1 T2 over P2 T1. And that's basically all we need to do here. This is what we mean by solving for one variable in terms of the other variables. When you do this, you really want to make sure that once they get more complicated, that if you're solving for V2, you want to make sure there are no V2s on this side, because if there are, you haven't really solved for V2 yet. So keep that in your mind as we proceed, and make sure you can do a simple problem like this also before we proceed. So here we have another problem. Even though it doesn't look like it, maybe it is actually a proportion too. So notice if I write it as V over 1 equals pi r squared h over 3. Now you can clearly see that it's in A over B equals C over D form, and we can go ahead and cross multiply and set these two cross products equal to each other. So we end up with, notice that we're solving for h, so we get pi r squared h equals 3v. So now we want to get h by itself, so we'll go ahead and divide both sides by pretty much everything but h on the left side. So we're going to divide by pi r squared. This, by the way, is the formula for the volume of a cone. You may have seen it before. So now we're going to cross cancel the pi's here and the r squareds, and that's it. We end up with h equals 3v over pi r squared, and that's all we need to do for that one. Again, make sure you can do that on your own before we move on. Here's another formula that's probably familiar to you. This is the formula for Celsius to Fahrenheit conversion. You basically plug in a Celsius measure here, and when you calculate that, they'll tell you the Fahrenheit amount. This will be a good formula to know for those of you who are only comfortable with Fahrenheit measure in case you go pretty much anywhere else in the world, because pretty much anywhere else in the world they use Celsius, so measure for temperature. By the way, a good approximation, notice 9/5 is almost 2, and a lot of people, when they want to get a quick conversion, they just double the Celsius amount, and to compensate for the fact that this is actually a little bit less than 2, they instead add 30. So if you want to get a good estimate and you're overseas and somebody tells you it's 30 degrees, you want to know what that means. You want to double, so 2 times 30 is 60, and add 32, that's 92. So it's a very warm day, for example. Now, of course, that's approximate. This is exact, okay? So we want to go ahead and solve this formula for C so that we can get the Fahrenheit to Celsius conversion, in case you have a friend who's come over to the United States and they have no idea what the Fahrenheit temperatures feel like. So you can give them that formula that we're about to obtain to do so. So we'll go ahead and start with writing the formula down. And the best way to handle any equation that has fractions in it is to actually get rid of the fractions. That's the most efficient approach. So we notice that the LCD for the entire equation is 5, so we'll go ahead and multiply both sides by 5. So we're going to do that like this. And on this side, once we multiply by 5, notice it has to be distributed, so we might as well just go ahead and distribute it and write it like that. So each term needs to get multiplied by 5. Now we cross cancel as much as we can. We notice here that's the only cancellation we have. So we end up with 5f equals 9c plus 5 times 32 is 160. So now we go ahead and move the 160 to the other side. So we get 5f minus 160 equals 9c. So of course we simply subtracted 160 from both sides. Now finally we're ready to solve it. So we're going to go ahead and divide both sides by 9. So we end up with c equals 5f minus 160 over 9. So you can provide that to your friends from overseas in case you're in the US and they ask you what 80 degrees Fahrenheit actually means. Then they can plug in the 80 in here and they can obtain the Celsius measure, which they are more comfortable with. All right, so make sure you can do that simple problem before we proceed. All right, so here we have that formula that we saw earlier for the area of a trapezoid, and sometimes you may see this formula written in this form: a equals 1/2 h times b1 plus b2, and it's the same thing, so you can work with either one of those two forms. Anyway, we want to solve this for b2. Notice once again what we have here. We have a proportion, don't we? In fact, if you write it as a over 1 equals h times b1 plus b2 over 2, now you can clearly see it's in a over b equals c over d form. You never want to miss the proportion form because it's so easy to work with. So now we're going to go ahead and cross multiply. Lost my screen there for a second. Okay, we're back. I don't know what happened there, but here we go. So we get h times b1 plus b2 equals 2a. All we did here is we cross multiplied. So we get h. Notice that the b1 here is trapped. There are a couple of ways of dealing with this. I'll show you both. One way is to distribute the h. So we get h b1 plus h b2 equals 2a. Notice that we can now go ahead and start isolating the b2. So we move the hb1 to the other side. So we get hb2 equals 2a minus hb1. Now we can just divide both sides by h and we should be good to go. So we end up with b2 equals 2a minus hb1 over h. All right, so that's one way. Or when we were here, we could have handled it differently as well. We could have, let me write that down again. So we have h times b1 plus b2 equals 2a. We could have gone ahead and divided both sides by h. And that would give us b1 plus b2 is equal to 2a over h, because on the left side the h's would cancel out. So notice we can quickly solve it for B2 now by just moving the B1 to the other side or subtracting B1 from both sides. So we end up with this. Now you may be thinking they look different, right? But notice if I go ahead and throw a 1 down here and combine those, we're going to have to multiply top and bottom of this by h. That's times, actually not a minus. It looks like a minus. So now we end up with 2a minus b1h over h, which if you notice is exactly the same now. So you could leave the answer like that, or you could go ahead and convert it to that. All right, so make sure you're comfortable with that before we proceed. All right, here we want to solve this equation for b. As always, try to do this on your own before you rejoin the video. So obviously we're going to try to get b isolated. So let's start by moving all the b terms to one side. It looks like the left side is a good place for them to all get together. So we have ab plus bc. We'll move the negative bf to the left side and it'll become plus bf equals cd. So now we do have all the b terms on one side, but we need to still get it isolated. So this is when factoring comes in, right? So we notice that we can factor out the b, and that leaves us a plus c plus f equals cd. So now all we have to do is divide both sides by this expression and we should be done. So we're going to divide both sides by a plus c plus f, and now these will cancel out and we end up with b equals cd over a plus c plus f. All right, and that should do it for that one. So easy one, but required a little bit of something that we didn't have to do in the previous ones, factoring. Try it on your own and then we'll go to the next one. So here's another formula we saw earlier for the potential energy that's hidden inside a mass with the amount m, and here c is the speed of light and we're going to solve for it. So we're going to keep in mind the fact that here we're dealing with speed, so we want our answer to be positive. So we have E equals mc squared. We're going to go ahead and divide both sides by m. So we get c squared equals E over m. Now, since we're solving for c, we're ready to go ahead and apply the square root property. Let's remember what the square root property said. It said if you have x squared equals k, that implies that x must be plus or minus square root of k. So here, what's playing the role of x is c, and what is playing the role of k is E over m, right? So we end up with c equals plus or minus square root of E over m. Now, if the problem had been presented to you without all the explanations, such as what each letter stands for, you would have given this as your final answer with both the plus and the minus. But since we specified what they are and we know that c is the speed of light here, we're only going to take the positive case. So for the final answer, in a presentation like this, we'll just put square root of e over m, but we make sure that we do what we always have to do, which is to rationalize denominators. But we do only take the positive case. So we get square root of e over square root of m. And now we're going to rationalize by multiplying top and bottom by square root of m. So we end up with c equals the square root of e m over, we know that square root of m times square root of m is just m, and that's how we leave it. So this was a little bit different because we had to apply the square root property. Make sure you can handle it before we move on. For our next problem, we're going to solve this formula, which gives the volume of a right circular cone for the radius r. So we go ahead and start with v equals 1/3 pi r squared h. Notice that we can write this in the following way. We can write it as v over 1 equals pi r squared h over 3. Now it puts it in the form of a proportion of the form a over b equals c over d, which implies we can cross multiply and get AD equals BC, correct? So we're going to do the same thing over here. We're going to cross multiply, so we get pi r squared h times 1, which is just pi r squared h, equals 3 times v, right? And now, because we're solving for r, we're going to go ahead and isolate the r squared term first. So we go ahead and divide both sides by pi times h. Let me write this a little further up. Ideally, your fraction line should be centered around the equal sign, so you want to be real precise, okay? And then we do the same on the right side, of course. So now we notice that we can cancel out the pi and h on the left side. So now we have, let me go back to the other color. So we have r squared equals 3v over pi h. So now we notice that we are in this form, x squared equals k, which we know implies x equals plus or minus square root of k by the square root property, correct? Which is called, if you remember, the square root property. So we end up with r equals plus or minus square root of 3v over pi h, okay? And let me go ahead and transfer that up here, because as you know, we have more work to do with this, given that there are going to be radicals in the denominator. So in order to deal with that and to rationalize the denominator, what we will do is we'll go ahead and split that up. So we get plus or minus square root of 3v over the square root of pi h. And now we'll go ahead and rationalize by multiplying both the numerator and denominator of this fraction by this radical. So we get the square root of pi h, and then the same on the top. So now we notice that we get plus or minus square root of, because these indices are the same,
we can go ahead and multiply under the radical to get 3. I'm going to put the pi next to the 3 because that's also a constant we know of. And then VH over, now we know that the square root of any number squared, which is the same as the square root of a number times the square root of the same number, just gives us the number, right? So as long as the n is positive, right? So we notice that here we have that scenario, so we're just going to end up with pi h. Now, if they had specified for us that we're dealing with a right circular cone and this is the volume formula for it, then we wouldn't have accepted the negative case because the volume of a cone can't be negative. But because this is just a pure theoretical problem asking us to solve for R for R to give us some practice, we will accept both of those answers. So when you type that in, you will go ahead and type both answers in. So they're both acceptable as far as just solving a formula for a variable goes. Now, if this was a real life situation and we were dealing with a situation where we were actually calculating the volume of a cone, we would have only accepted the positive case. Make sure you can handle that on your own before you move to other problems.
So, okay, so here we have Newton's universal law of gravitation, which explains how objects are drawn to each other. Now, this time we know that, and so we know that this mass is going to, M1 is going to be representing one of the two masses. So, once again, we're going to be wanting only positive results because mass can't be negative. So, do notice once again we have ourselves a proportion. These are very common, that's why I want you to get very comfortable with handling them quickly. So we get gm1 m2 over r squared. We're solving for m1. We're going to go ahead and cross multiply, so we get gm1 m2. One of the really important things in formulas is to make sure that you watch the capitalization, whether something is lowercase or uppercase. Sometimes in the same formula you have the same letter in both its uppercase and lowercase formats, and they will be standing for completely different things. So it's very important to watch case. All right, so we are solving for m1, so here we're just going to divide both sides by gm2. Now g's will cancel out, m2's will cancel out, and we'll be left with m1 equals fr squared over gm2. And here we did not even have to worry about taking square roots or anything like that, so we are done. All right, so make sure you can do that and we'll proceed. All right, so this time we're asked to solve the same equation, Universal's law of gravitation by Newton, but we're asked to solve it as a general equation. In other words, we're asked to forget that it's Newton's universal gravitation law, and it's actually nicer to say it as Newton's law of universal gravitation, but this will work too. We're asked to solve it for r, and we're going to assume that r can be -2. R is actually the distance between the two objects. So, but we're not going to assume that. We're just solving this as purely a mathematical equation. So here we're going to get f equals gm1 m2 over r squared. We're solving for r. We're going to go ahead and put a 1 here, and notice we have one fraction equals one fraction, anytime we have that, we can cross multiply, so we get f r squared equals g m1 m2. Make sure you don't put these above on top. These are subscripts, not exponents, which are known as superscripts. We use subscripts to get a lot more mileage out of just one letter, you see. So if you don't use subscripts, then you can use a letter in an application only once, but when you use subscripts, you get to use it many times over, and each one can stand for a different variable. All right, so now we're going to get rid of the f, so we'll go ahead and divide both sides by f. Now we notice that here they will cancel out, so we end up with r squared equals g m1 m2 over f. And now we're going to go ahead and apply the square root property. Remember, x squared equals k implies x equals plus or minus square root of k. Notice that here what's playing the role of x is r, and what's playing the role of k is all of that, gm1 m2 over f. It's this ability to be able to generalize that helps you advance in mathematics. So here we end up with r equals plus or minus square root of g m1 m2 over f. And of course, we're not going to leave it like that. We will accept both the positive and the negative, since we're asked to not assume anything about this equation, but we do need to rationalize the denominator. So we're going to go ahead and break it up. And now we'll multiply top and bottom by square root of f over square root, so just like that. And we end up with plus or minus square root of g m1 m2 f on the top. Downstairs we just get square root of f times square root of f, which is just f. So that's how we leave our final answer. So make sure you can do this on your own, and then we'll proceed to another one.
All right, next we want to solve this particular quadratic for t. So basically t is the only letter we're going to treat like a variable, and we will treat all the other letters like a constant, like similar to -64 or 5, 10, etc., pi. So in order to put this in standard quadratic form, which helps us get to a point where we can apply the quadratic formula, we'll go ahead and move all terms to the left side and get 0 on the right side. So moving all three of these to the left side, of course we'll change the sign, so we get 64t squared minus kt plus h minus c equals 0. I put the h first just so that we could have a positive lead, just because it looks nicer, no other particular reason. And then the c, so that becomes minus c. So now we're going to, now we notice that we are in basic quadratic form, which is basically a times some expression squared plus b times the same expression plus a constant equals 0. So in this case, the expression that's being squared and also appearing in first degree form is t. So this we call a quadratic in t. Notice that if we were solving for any other letter, it would have just been a linear equation in that variable, because all the other letters other than t only have a first degree term, right? So if we were solving for any letter other than t, we would just solve it as if it were a linear equation. But now we're solving for t, and in t it is indeed a quadratic. So we need to go ahead and determine a, b, and c at this point. So make sure that all the signs have been handled correctly. And yes, everything is as it should be. So now we say a equals 64. B, which is the coefficient of t, is going to be the negative k. And c, which is that entire expression, is going to be h minus c. So don't let this confuse you. We're just using the a, b, and c as the original constants from the standard quadratic form. So treat this as a different c. There we go. So now we're going to go ahead and solve for t using the quadratic formula. As always, we will write the formula first, so without plugging in, right? So we get t equals negative b plus or minus square root of b squared minus 4ac over 2a. Now we carefully substitute. So we know that b is negative k, and the opposite of negative k is just k, right? So k plus or minus square root of b squared. So b is negative k. Of course, when we square negative k, we just end up with negative squared becoming positive, and we end up with just k squared, right? So that's what we're going to write instead of b squared. Minus 4 times a, which is 64, times c, which is, of course, all of that. So h minus c. And then all of that over 2a. So 2 times 64. Okay? So we just going to clean up at this point. So k plus or minus square root of k squared minus 4 times 64. We can do this in our head. 4 times 60 is 240, and 4 times 4 is 16. 240 and 16 add up to 256. So minus 256 times h minus c. So a multiplication like that, of course, on a stressful test day or something, you'll want to verify that on a calculator for sure. Okay? And then over, now 2 times 64, of course, we can do in our heads too. 2 times 60 is 120, and 2 times 4 is 8. We add those, we get 128. So in other words, we're using, when you do that in your head, you're using the distributive property. This is what's going on in your head, okay? So you're saying 2 times 60 is 120, 2 times 4 is 8, then you're adding those to get 128, okay? Just a little side note. That's the same thing we did with 4 times 64. 4 times 60 plus 4, right? So that's 240 plus 16. That's how we get the 256, okay? So that's what's going on in our heads. All right, and down below we get 128. We're almost finished. So we get k plus or minus square root of k squared. Now we're going to distribute the negative 256. So we get minus 256h. And then negative times negative becomes positive, so plus 256c. And all of that over 128. So there is our final answer. Of course, there are two answers. One comes from the plus case and one from the minus case. So some homework systems on a computer allow you to type that in using the plus or minus, and some of them make you write it out as two separate solutions. Of course, just write one of them copy, comma, paste, and then just change the plus to minus, etc. All right, so that's how you do that one. It's a great problem, so make sure you can do it on your own without any help before you proceed.
All right, so here we have a square root situation, and we're going to solve for m. Of course, the first thing we'll want to do is see if we can get rid of this square root, and that's easy enough. We know that we need to go ahead and square both sides. So we end up with this. Maintain the case of every letter if it's capital or lowercase. All right, so we end up with a squared equals, we know that the square root of any radicand squared just gives us the radicand. So here we're just going to get 144 dm over v. Now, keep your eye on the target, which is m. So again, I hope you realize we have ourselves a proportion. We're going to cross multiply. So we get 144 dm equals a squared v. And since we're solving for m, we're going to want to get rid of everything else there. So we're going to divide both sides by 144 d. And we'll cross cancel these, the 144 and the d, and now we have our final answer. M equals a squared v. And make sure that doesn't look uppercase, over 144 d. So definitely pay attention to the case on every letter, and you should be fine. So anyway, so make sure you can handle that, and we'll go to another one. All right, for our last example, we have a right triangle, and we're trying to solve for one of the sides in terms of the other two sides. So of course we know that in a right triangle, leg 1 squared plus leg 2 squared equals the hypotenuse squared. That's the format which I recommend, because with A, B, and C one can get in trouble, because if you get too attached to those letters and somebody shows you this right triangle and you try to say a squared plus b squared equals c squared, this would of course be wrong, because the correct equation here would be b squared plus c squared equals a squared. So I recommend getting away from those letters and actually just remembering it like this, because with this you can't go wrong, because we know that the two sides that form the right angle are called legs, so we'll just call them leg 1 and leg 2. And we know that the largest side, which is opposite the largest angle, is the hypotenuse, so we can call that h. All right, so now we can think of this one as L1, think of Z as L2, and think of this as H. So we end up with x squared plus z squared equals y squared. Now we're solving for x, so we're going to go ahead and isolate it. So we get x squared equals y squared minus z squared. So we get x equals, now we're going to apply the square root property. Let me remind you, if x squared equals k, then x equals plus or minus square root of k. Here x is actually playing the role of x, but k is being played by y squared minus z squared. So we get plus or minus square root of y squared minus z squared. We always have to have common sense active when we're solving actual situations which deal with objects, because here we obviously can't have a negative length for x because it's the length of a side of a triangle. So we will reject the negative case because the square root we know will be non-negative, and in fact it'll be positive. So when you multiply it by negative, it'll definitely become negative. So we have to reject the negative. So we're only going to accept the positive case. We get y squared minus z squared. And that should pretty much wrap that up. There's only one thing I really want you to be careful about, and that is to make sure you don't say that this is equal to y minus z, because it absolutely is not. The reason students make that mistake is because if it were multiplication, it would work. If you had the square root of y squared times z squared, you could say that's yz, but the fact of the matter is that the square root of a sum is not the sum of the square roots. It just does not work that way. And nor does the square root of a difference equal to the difference of the square roots. Both of these are dissimilar to the case with multiplication and division. It works for them, but it doesn't work in these cases. And of course, it's not difficult to see why they're not true, because remember, in mathematics, all you need is one example to know that something should not be done. Here is the counter example. For example, let's say we look at the square root of 25 minus 16. Now, we know that that's the square root of, if we do it correctly, 9, which is 3. But now look at the square root of 25 minus the square root of 16. The square root of 25 is 5. The square root of 16 is 4. So here you would get 1. And of course, see, they're different. And of course, this is correct and this is incorrect as far as this expression is concerned. So this is correct as far as a computation goes, but I'm saying as far as which one of these forms are correct as far as handling this expression is concerned, you should go with this method, which is subtract those first, then take the square root. So make sure you don't make the mistake of just taking the square roots off and writing y minus z. As long as you do that, you should be good to go. So that should do it for this video. Be safe until our next meeting, and make sure you practice these till you're really comfortable with them.